BAE Systems PHASA 35, which is a solar electric high altitude pseudo satellite, completed a 24-hour flight, reaching over 66,000 feet and cruising into the stratosphere. The aircraft itself landed in a serviceable condition, ready to fly again just 2 days later, which those MRO and those are some rapid turnaround capabilities. That's huge. The PHASA 35 is designed to provide persistent surveillance, communications, and environmental monitoring with the potential to stay airborne for up to a year. Huge. The successful flight itself marks a significant milestone in the development of solar-powered unmanned aircraft. The aircraft's design includes a 35-meter wingspan, which feels massive, and ultra-lightweight solar cells, enabling it to harvest energy from the sun and produce zero emissions. This was developed in collaboration with Prismatic. The PHASA 35 aims to transform the air and space, and it sounds like they're already doing that.
Yeah, it's not, the challenge here isn't getting this thing to fly. It's making sure it can keep flying for a year straight without crashing, without freezing, or turning into some kind of giant solar-powered paperweight in the stratosphere. So keeping it going.
Yeah, the goal you said was a year, and right now we're looking at is the first flight that was 24 hours, which is still cool, but that's not yet a year, right? That's all, what, 1/365th of the way there. But being able to climb that high, over 60,000 feet, cruise the stratosphere, successfully land in a serviceable condition, and being able to be flight ready just a couple of days later is a great milestone. But this is still in development. They've got to take the results from this, fine tune them, integrate those changes into the design, and keep on building.
Yeah, I agree with all of that. But asking it to survive for 12 months in the stratosphere, it's like asking your phone to last a week without a recharge for me. And mine's struggling with 6 hours these days. It's ambitious. It's kind of borderline unrealistic, and it's hinging on flawless engineering.
Well, the way you get there is to test, to change, to build those changes in, to test, change, build, test, change, build. So, I mean, I think that this is just that process of, hey, it's worked for 24 hours. Now we got to make it work for a year.
Yeah. So you've really got to kind of ensure your solar efficiency and your energy management systems are going to support continuous operations. You're going to have to validate the design and materials for extreme stratospheric conditions. Make sure you've got your real-time monitoring and your adaptive systems to handle the environmental changes. So I don't know, what do we focus on here? To me, it's testing and simulation, isn't it?
Yeah, and that's where, like, you're looking at your product validation or simulation, where the real test of this long-term flight in the stratosphere is going to lie. How do you implement that is looking at stratospheric environment simulations, the computational fluid dynamic models to simulate airflow, turbulence, pressure, use all this, test the material durability against UV exposure, temperature fluctuations, the low atmospheric density. So there's a lot of, as we said, testing that just got to go on here.
Yep. And your energy management and your aerodynamic stability testing, your failure mode simulations, your field validation, whole bunch of product validation and simulation. See you next week.